Deep beneath the rugged, sun-scorched peaks of the Zagros Mountains lies one of the most heavily fortified military secrets of the modern era. Welcome to Science Aura. I am Dr. Sachi Vale. Today, we peel back layers of solid granite to explore Iran's underground missile cities, vast but subterranean labyrinths designed to withstand the world's most sophisticated weaponry and reshape Middle Eastern geopolitics. For decades, spy satellites have scanned every square inch of the Iranian plateau. High-altitude cameras and radar systems track military movements in real time. To survive this relentless eye in the sky, Iran realized that building on the surface was a death sentence. The solution was simple yet monumental: disappear entirely into the earth, carving out a fortress where satellites cannot see. Known locally as Shari Mushaki, or missile cities, these subterranean bases are not mere bunkers. They are sprawling, self-sustaining military complexes, housing thousands of soldiers, advanced assembly lines, and arsenals of ballistic missiles. They represent a masterclass in asymmetric warfare, turning geological features into an impenetrable shield against superior air power. By placing their strategic assets deep underground, Iran alters the calculus of deterrence. No longer can an adversary hope to eliminate their missile force in a single, preemptive strike. This calculated vulnerability reduction forms the bedrock of Iran's defense strategy, forcing rivals to reconsider the true cost of any potential military confrontation. But how did Iran construct these massive bases under hundreds of meters of solid rock? And why are conventional weapons completely useless against them? To understand the sheer scale of this engineering feat, we must first look at the unique geology of the Zagros Mountains, a natural barrier that has protected Persia for millennia. The Zagros Mountains were formed by the collision of the Arabian and Eurasian tectonic plates. This immense pressure compressed the rock into incredibly dense, highly resistant layers of granite and limestone. It is this specific geological composition that provides the ultimate natural armor, far superior to any man-made concrete structure. Granite has a high compressive strength, meaning it can absorb massive amounts of kinetic energy without fracturing. When a bomb detonates on the surface, the shock waves are dispersed through the dense crystalline matrix of the rock. This natural dampening effect makes the deep tunnels beneath almost immune to the destructive force of conventional explosives. Many of these missile cities are buried at depths ranging from 300 to over 500 meters. At these depths, the pressure of the overlying rock is immense, requiring highly specialized engineering to prevent tunnel collapse. Yet, this same crushing overburden is what protects the bases from even the heaviest precision-guided munitions. To put this in perspective, 500 meters of solid Zagros granite is equivalent to a shield of reinforced concrete, several kilometers thick. For any conventional weapon to penetrate this barrier, it would have to defy the laws of physics. The mountain itself acts as a permanent passive defense system that requires zero maintenance. By leveraging this geology, Iran has effectively neutralized the precision strike capabilities of its adversaries. The GPS-guided bombs that decimated surface bunkers in Iraq and Libya are rendered useless here. The Zagros Mountains have been transformed from a geographic barrier into an active component of national defense. But carving these complexes was an engineering nightmare. Tunnel boring machines, explosive blasting, and continuous rock bolting were required to stabilize the massive caverns. Iranian engineers had to work in absolute secrecy, disposing of millions of tons of excavated rock without alerting foreign intelligence agencies. To reinforce the tunnels, engineers utilized thick layers of fiber-reinforced shotcrete and heavy steel arches. These hexagonal concrete tunnel reinforcements are designed to flex slightly under seismic stress, preventing catastrophic cave-ins during an earthquake or a nearby missile strike. Every meter of the tunnel is a feat of structural resilience. The sheer volume of excavated material posed a massive security risk. To hide the scale of construction, excavation was often done at night, and the waste rock was mixed into local construction projects or hidden in deep, natural ravines. This meticulous attention to detail kept the true extent of the projects hidden for years. The missile cities are built using a modular design. Instead of one massive cavern, they consist of a network of interconnected tunnels, blast chambers, and living quarters. If one section of the base is breached or damaged, heavy blast doors can seal it off instantly, allowing the rest of the facility to continue operating without interruption. These blast doors are masterpieces of heavy engineering. Constructed from high-strength steel and filled with reinforced concrete, they can withstand pressures of several hundred atmospheres. They are designed to seal hermetically, protecting the interior of the base from toxic gases, fire, and the overpressure of surface explosions. Step inside one of these complexes, and you enter a subterranean city. The main tunnels are wide enough to allow 2 heavy missile transporters to pass each other. The walls are lined with electrical conduits, ventilation ducts, and communication lines, all neatly organized to ensure maximum reliability during a crisis. At regular intervals, the tunnels widen into massive storage depots. Here, rows of ballistic missiles are kept on mobile launchers, prepped and ready for deployment. The air is cool and dry, carefully conditioned to prevent corrosion and protect the delicate electronic guidance systems of the missiles. To protect the sensitive missiles from ground tremors, the storage racks and launch platforms are mounted on advanced seismic dampening systems. These giant spring-loaded shock absorbers isolate the equipment from any external vibrations, ensuring that even a nearby subterranean detonation will not damage the guidance system. Living in these underground bases requires a unique psychological resilience. Soldiers and technicians spend weeks at a time deep underground, cut off from natural sunlight. To maintain morale and alertness, the facilities include modern barracks, gyms, dining halls, and even artificial lighting systems that mimic the natural cycle of day and night. At the heart of each missile city is a state-of-the-art command and control center. From here, commanders can monitor external threats, coordinate missile launches, and communicate with the high command in Tehran. These centers are protected by multiple layers of electromagnetic shielding to survive high-altitude nuclear EMPs. Evading modern satellite surveillance requires more than just hiding under rock. Satellites use thermal imaging to detect the heat generated by underground facilities, such as ventilation exhaust and power generators. To counter this, Iran utilizes advanced thermal masking systems, cooling the exhaust air before it is released into the atmosphere. Another key tactic is the construction of decoy exits and fake construction sites. For every real tunnel entrance, there are several dummy portals designed to confuse satellite analysts. These decoys are equipped with fake vehicles and heat sources, drawing the enemy's attention away from the actual launch sites. The real entrances are masterpieces of camouflage. They are often hidden within natural rock fissures, covered by high-tech netting that mimics the radar and visual signature of the surrounding granite. To the untrained eye, and even to advanced satellite radar, these entrances are completely invisible, appearing as solid rock. Strict operational security is maintained at all times. Vehicle movements in and out of the tunnels are tightly scheduled to coincide with gaps in satellite coverage. Soldiers and staff are forbidden from carrying personal electronic devices, eliminating the risk of accidental signal leaks that could give away a base's location. Within the bases, all communications are routed through a closed fiber optic network. This complete electronic silence prevents foreign signals intelligence from intercepting data or pinpointing the coordinates of the command centers. The missile cities operate in a digital black hole, invisible to the electromagnetic sensors of the outside world. A critical element of Iran's underground strategy is its transition from liquid fuel to solid fuel ballistic missiles. Unlike liquid fuel missiles, which must be fueled immediately before launch, a process that takes hours and can be easily detected, solid fuel missiles can be stored fully loaded and ready to fire at a moment's notice. Missiles like the Sachi and the Fateh series are the backbone of this underground arsenal. These solid propellant rockets are highly reliable, have a long shelf life, and require minimal maintenance. This makes them perfect for long-term storage in the humid, subterranean environments of the Zagros missile cities. Because solid fuel missiles are ready to launch, they can be rolled out of the tunnels, fired, and the launcher returned to safety before an enemy can react. This rapid deployment capability is the key to Iran's offensive strategy, allowing them to execute devastating retaliatory strikes with almost no warning. In recent years, Iran has focused heavily on improving the accuracy of its missiles. By integrating advanced inertial guidance systems and GPS-independent terminal seekers, these weapons can strike high-value targets across the region with pinpoint precision, turning a simple deterrent into a highly effective offensive tool. The sheer scale of the underground arsenal is staggering, Estimates suggest that Iran possesses thousands of ballistic and cruise missiles, all safely tucked away beneath the mountains. This massive stockpile ensures that even in a worst-case scenario, Iran would retain a significant retaliatory capability. The primary operational doctrine of the missile cities is the shoot-and-scoot tactic. In a conflict, a mobile launcher will emerge from a hidden tunnel portal, raise its missile, fire, and immediately retreat back into the safety of the mountain. The entire process takes less than 10 minutes, leaving no time for a counterstrike. Once the missile is launched, the vehicle is already moving back toward the tunnel before the missile even clears the atmosphere. By the time enemy satellites detect the launch plume and calculate the origin coordinates, the launcher is already safe under hundreds of meters of solid granite, ready to reload. Inside the tunnels, specialized reloading bays are equipped with heavy overhead cranes. Within minutes of returning, the launch vehicle is loaded with a fresh missile, its systems checked, and prepped for another mission. This highly efficient cycle allows for continuous, sustained bombardment during a conflict. By coordinating launches from multiple missile cities simultaneously, Iran can execute devastating swarm attacks, overwhelming enemy air defenses with dozens of incoming missiles at once. These coordinated strikes can saturate even the most advanced missile defense systems, ensuring that a significant number of warheads reach their targets. This operational flexibility makes the missile cities incredibly difficult to counter. They are not static targets that can be systematically destroyed. They are dynamic, shifting networks of fire that can adapt to changing battlefield conditions in real time, keeping the adversary constantly on the defensive. To counter these underground fortresses, Western militaries have developed massive, specialized bunker buster bombs, such as the US GBU-57 massive ordnance penetrator. Weighing over 14,000 kilograms, these GPS-guided giants are designed to penetrate deep into concrete and soil before detonating. But even the GBU-57 has its limits. It is designed to penetrate up to 60 meters of reinforced concrete or dry earth. Against 300 to 500 meters of solid, tectonic, compressed Zagros granite, even the most powerful conventional bunker buster is completely ineffective, merely scratching the surface of the mountain. The physics of kinetic penetration dictate that as a projectile travels through a dense medium like granite, it rapidly loses velocity and deforms due to the extreme heat and friction. No conventional material can survive the immense forces required to drill through hundreds of meters of solid rock at high speed. This creates a profound dilemma for military planners. An air campaign designed to eliminate Iran's missile threat would require thousands of sorties and would likely fail to destroy the core underground assets. The conventional options are simply insufficient to crack the granite shield of the Zagros. This is the ultimate triumph of Iran's asymmetric strategy. By investing in geological engineering rather than expensive air defenses, they have neutralized the primary offensive tool of their adversaries. The mountain has done what no surface-to-air missile system ever could, rendered the enemy's air power obsolete. To survive a prolonged siege or a full-scale war, these missile cities must be completely self-sustaining. They are equipped with massive underground water reservoirs, independent power grids powered by deep geothermal or diesel generators, and sophisticated air filtration systems designed to keep out chemical and biological agents. Power generation is critical. The bases utilize heavy industrial diesel generators housed in separate heavily ventilated chambers. These generators are mounted on vibration dampening pads to prevent their noise from being detected by surface acoustic sensors, ensuring the base remains a silent ghost. Air filtration is another engineering marvel. The ventilation systems pull air from hidden intakes high up on the mountain slopes, passing it through multiple stages of HEPA and activated carbon filter. This ensures that even if the surface is contaminated by chemical weapons, the air inside remains pure and breathable. Massive food depots and fully equipped medical clinics are integrated into each complex, stocked with enough freeze-dried rations, medical supplies, and surgical equipment to last for months. Of these facilities ensure that the garrison can survive and fight, even if completely cut off from the outside world by a blockade. Water is sourced from deep artesian wells drilled directly beneath the bases. This independent water supply is immune to surface contamination or sabotage, providing a continuous flow of fresh water for the personnel and the cooling systems of the high-power electronic equipment inside the base. The command and control structure of the missile cities is highly decentralized. Each base is designed to operate autonomously if communication with the central command is lost. This ensures that even if Tehran is targeted, the missile cities can still execute coordinated retaliatory strikes on their own initiative. Redundancy is built into every layer of the communication network. Secure fiber optic cables, buried deep underground, connect the bases in a ring configuration. If one link is severed, data is automatically rerouted through other paths, ensuring uninterrupted command and control under the most severe conditions. To protect against electromagnetic pulse weapons, which can fry electronic circuits across vast areas, the command centers are housed within Faraday cages. These continuous copper and steel shields absorb and redirect electromagnetic energy, keeping the vital computers and communication gear safe from harm. For external communication, the bases utilize highly directional, low probability of intercept satellite uplinks. The antennas are retracted into armored silos when not in use, emerging only briefly to transmit encrypted data bursts before disappearing back into the safety of the rock. Ultimately, the effectiveness of this decentralized command structure relies on the training and discipline of the officers. Handpicked for their loyalty and technical expertise, these commanders are trained to make critical decisions in high-stress, isolated environments, ensuring the deterrent remains credible. Given the near-total immunity of these bases to conventional weapons, military analysts agree on a sobering reality. Only tactical nuclear weapons possess the sheer energy required to destroy these underground fortresses. This stark truth elevates the strategic value of the missile cities to a global scale. A Earth-penetrating nuclear weapon would detonate below the surface, creating a massive ground shockwave that would crush the tunnels and blast doors, neutralizing the base. However, the use of such a weapon would cross a threshold that has remained untouched since 1945, with catastrophic consequences. The geopolitical fallout of a nuclear strike would be immense. It would shatter international norms, trigger an environmental disaster of unprecedented proportions, and likely ignite a regional or global war. The mere threat of such an escalation acts as a powerful deterrent, protecting the missile cities from attack. This creates a perfect deterrent loop. The bases are too deep to be destroyed by conventional means, and the nuclear option is too dangerous to ever be seriously considered. Thus, the Zagros missile cities remain practically invulnerable, securing Iran's position as a major regional power that cannot be easily coerced. This strategic standoff is the ultimate goal of Iran's military planning. By forcing their adversaries into a position where the only path to victory is too costly to contemplate, they have achieved a high level of security without the need for a matching conventional military budget. Iran's underground missile cities are a testament to the power of asymmetric thinking. By combining geological engineering with advanced missile technology, they have built a fortress that challenges the military dominance of the world's most advanced superpowers, rewriting the rules of modern warfare. From a purely scientific and engineering perspective, these complexes are a triumph of human ingenuity. They demonstrate how a nation under severe economic sanctions can still build and maintain some of the most sophisticated defensive structures on Earth, turning adversity into a strategic shield. As we look to the future, the lessons of the Zagros Mountains will undoubtedly shape how other nations approach defense. In an era of absolute satellite surveillance and precision strikes, going deep underground may soon be the only way to survive, making these missile cities a preview of the future of warfare. For Science Aura, I am Dr. Sachi Vale. The story of Iran's missile cities is a powerful reminder that in the grand game of geopolitics, the Earth itself remains the ultimate player. The rocks beneath our feet can be as powerful as any technology we create, shaping history in ways we are only beginning to understand. Thank you for joining us on this deep dive. If you enjoyed this exploration of the intersection of geology and military engineering, don't forget to like, subscribe, and share your thoughts in the comments below. Until next time, keep exploring, keep questioning, and stay curious.